Today's video is all about the important terms in linear block codes. So first is Hamming weight. So what is Hamming weight? It is nothing but number of ones in a code word. So suppose it is a code word 1. This is a 7-bit code word. In this code word you have to count how many number of ones are there. So in this code there are 5 ones. So its Hamming weight is 5. In second code word, Hamming weight is 0. Next term is Hamming distance. So Hamming distance is between two code words. So the number of places where two code words differ is called Hamming distance. So for example, this is code word 1 and this is code word 2. So if you observe, these code words differ at one position. That means here 1 is there, here 0 is there. Otherwise here 0 is there, 0 is there, 1 is there, 1 is there, 0 is there, 0 is there. So its Hamming distance is 1. Another example is, so in this the code words differ at 4 places. So its Hamming distance is 4. So next term which is important in linear block code is a Hamming bound. So what is Hamming bound? So n comma k linear block code can correct up to TC errors if n and k satisfy the following Hamming bound. So what is that Hamming bound? 2 raised to n minus k is greater than or equal to summation I equal to 0 to tc nci. So for example, if n equal to 7 and k equal to 4 and it can correct one error, then here we put all these values. So 2 raised to 7 minus 4, n is 7, k is 4, is greater than or equal to I equal to 0 to tc is 1, 7ci. So you have to increase I from 0 to 1. So 2 raised to 3 greater than or equal to 7c0 plus 7c1. So you know 7c0 is 1. That is 7 factorial divided by 0 factorial divided by multiplied by 7 factorial. So that's a common, you can calculate it in calculator also. So 7c1 is 7. So 2 raised to 3 is greater than or equal to 1 plus 7. So here the equality is there, that is 2 raised to 3 is equal to 8. So if there is a equality, that code is perfect code. So what is Hamming bound? That means LBC should satisfy this Hamming bound. N is number of code word bits, K is number of message bits, and TC is number of errors it can correct. And if the equality is achieved, then that code is called perfect code. And here I just want to mention what is Hamming code. The linear block code with error correcting capability of 1 and which is also a perfect code. That means Hamming code is 1 where here the equality is there and TC is equal to 1. So that LBC is a Hamming code. So what is error detection capacity of the LBC? So an n comma k LBC with minimum Hamming distance d minimum can detect TD errors if d minimum is greater than or equal to TD plus 1. So this is the condition that Hamming distance is d minimum, it is greater than or equal to if TD plus 1 for LBC. And for error correction capacity of LBC, so that is d minimum is greater than or equal to 2tc plus 1. So these are important terms for LBC, for understanding LBC. So I hope you understood all these terms.